Hi, and welcome to our 120th test and measurement video. Today we'll review some basic oscilloscope functions. We've connected channels 1 and 2 in the Tektronix AFG3000 Series function generator via BNC cables to channels 1 and 2 in this Tektronix MDO3000 Series Oscilloscope. To begin in a basic way, we fed sine waves from one instrument to the other. Starting at the home page in the AFG using the touch screen, we've pressed Basic, which accesses the internal library of 12 standard waveforms, plus Arbitrary, which allows the user to create custom waveforms. Notice that sine wave is the default, shown in both channels. Also, we have to switch on the outputs for both channels in the AFG. The signals are being sent to the oscilloscope. Depending upon how the instrument was last used, it may be necessary to press Auto Set to set the frequency and amplitude parameters so as to get a meaningful display. When first powered up, only channel 1 is activated, so we had to turn on channel 2 and again press Auto Set. Also, we pressed Menu Off to get a full screen view of both sine waves. Notice that the dedicated channel colors are the same for both instruments, yellow for channel 1 and blue for channel 2. We see this for waveforms and controls in both instruments. A basic function in the oscilloscope is enabled by pressing the button labeled Measure. The fourth item in the horizontal Measure menu is Dvm Digital Voltmeter. Pressing the associated soft key, the vertical Dvm menu comes up, and we can turn multipurpose knob A to see AC plus DC RMS, DC, ACM RMS, and frequency. The volt readings may vary a little due to the cable impedance at this high frequency, but frequency is usually exact, 1 megahertz, which corresponds to precisely to the AFG output. Another useful function is accessed by pressing the Math button. Dual waveform math permits the user to perform the 4 arithmetic operations. Multipurpose knob A sets the first source, and multipurpose knob B sets the second source. The second vertical soft key determines operator, add, subtract, multiply, or divide. The yellow and blue waveforms are inputs from the AFG, and red is the dedicated color for math. Using the vertical cursor, it is easy to see what is going on. Here, for example, when adding waveforms, 0 in the 2 inputs equals 0 in the red waveform. Using the operator soft key, we can likewise subtract, multiply, and divide. Divide looks a little odd until you recall that you cannot divide by 0, so the oscilloscope is trying to display everything that lies between 0 and infinity. Going back to math, in the horizontal menu, press FFT, Fast Fourier Transform. This is not a dual waveform mode, so the single source is channel 1. Using multipurpose knob A, you can make it channel 2, which in this case yields the same result, since the 2 channels are displaying identical waveforms. So, for clarity, we'll turn off channel 2 and remove all menus. Now we're seeing in the same screen that yellow is the time domain display and red the frequency domain display. In the time domain, amplitude is shown in volts or fractions thereof, plotted along the y-axis, and time is plotted typically in milliseconds along the x-axis. In contrast, in the frequency domain, what you are still seeing is amplitude, now, however, expressed in units of power along the y-axis, and frequency typically is expressed in kilohertz, plotted along the x-axis. In the frequency domain, you generally see an irregular, roughly horizontal fluctuating line near the bottom of the display. In this red frequency domain display, there are no harmonics because in the sine wave, all the power is concentrated at a single frequency, known as the fundamental or first harmonic. So there are no second order or higher harmonics. The fundamental is difficult to see because it is crammed up against the left edge of the display. To bring it to the center, swing the channel 1 cable over to RF. Be sure to use an RF adapter. Turn on RF. In the RF section, press Frequency Span. Insert the sine wave frequency, in this case 1 megahertz, in the center frequency field. This brings the fundamental to the center of the display. Make the span 2 megahertz. To see the harmonics, switch channel 1 in the AFG to square wave. Change span to 20 megahertz. Press menu off for clarity so you can see the harmonics. Soon we run out of screen space, so make span 200 megahertz. To see still more, raise span to 400 megahertz. Now, because of decreased resolution, the harmonics are getting quite difficult to distinguish. Thanks for watching. New videos are added periodically, so check back frequently.